Hi there. Today we're going to be discussing about deciles for ungrouped data and how to use a simple formula to compute it. Deciles are measures of relative position that help us to understand the distribution of data by dividing the data into 10 equal parts. There are 9 deciles. D1, which is the first decile, D2 the second decile, then D3 all the way to D9. It is important to note that D5, which is the fifth decile, is the same as the median, which is the same as the second quartile. If you want to learn more about quartiles in statistics, then check out my video popping up right about now, or you can check the links in the description of this video. The formula for computing deciles is a simple formula that goes like this. Di is equal to I multiplied by n plus 1 in brackets, right, divided by 10. Please note that this formula only gives you the position of the decile, but not the actual value. That's why we have the th here as superscript, meaning the position. In this formula, the I stands for the decile number. So if we want to find the first decile, for example, then I will be 1. And then if we want the second decile, I will be 2, or the ninth decile, I will be 9. Alright? The actual value of the decile is obtained from the data set after getting the position using this formula. N in the formula is the number of data points in the data set. So let's try an example with data of serum albumin levels of 19 patients that were seen in the pathology lab of Ahmadu Bello University Teaching Hospital this morning. Let's go ahead and calculate the deciles for this data set. Before we can apply the formula, we will need to sort the data in ascending order. Great. Now, with the data sorted in ascending order, let's use the formula. For the first decile, I will be 1, right? And n is 19 because we had 19 individuals, right? So we have d1 is equals to 1 times 19 plus 1, all divided by 10. That will give us 20 divided by 10, and this will give us 2. So our D1 is in the second position. Remember, this formula only gives us the position, not the actual value of the decile. Awesome. So if we look at our sorted data, this is going to be on the second position. So our D1 is on the second position, meaning our first decile falls here. The value of our first decile is 2.5 grams per DL. Easy peasy. So let's try another decile. Let's clean this up. Okay. Let's do the fifth decile. That's D5, right? That's what we call the median also. Okay. So I here will be 5 and our n is 19. So using the same formula, D5 will be equal to 5 times 19 plus 1 in bracket, right? All divided by 10. That's 100 divided by 10. So our D5 is going to be in the 10th position. So looking at our sorted data, again, our 10th position is right about here. Awesome. Good. And you know D5 is the same as the median of the entire data set. Alright. So our D5, which is the median, which is the same as the second quartile, is 3.7 grams per DL. Great. So let's compute one more decile. Which one should we compute? How about we compute D10? Wrong. There's no such thing as D10. Many students make this mistake. There are only 9 deciles, and these 9 deciles divide the data into 10 equal parts. So the highest decile we can have is D9. So let's compute D9, shall we? So I here will be 9, and our n for this data is 19, right? So putting this into the formula, we will have D9 is equal to 9 times 19 plus 1 in bracket, all divided by 10. And this will give us 180 divided by 10. And so our D9 is going to be in the 18th position. So looking at our sorted data, our 18th position is right about here. So our 9th decile is 6.5 grams per DL. Great. So our D1 is 2.5 grams per DL, our D5 is 3.7 grams per DL, and our D9 is 6.5 grams per DL. Easy peasy. So what does this mean in the context of our data? Our first decile, D1, of 2.5 grams per DL means that 10% of our patients had serum albumin levels less than or equal to 2.5 grams per DL. And we can see this with the data that only 2 individuals, the first and the second patient, out of the 20 individuals had serum albumin less than or equal to 2.5 grams per DL. And 2 out of 20 is 10%, right? So we say our first decile of 2.5 grams per DL means that 10% of our patients had serum albumin levels less than or equal to 2.5 grams per DL. Awesome. So we can use this to explain the distribution of our data, and that's what deciles are meant for. Great. And now you know how to compute and interpret deciles for ungrouped data. Awesome. So can you compute and interpret the third decile for this same data? Please put your answers in the comment section below, and please do not ignore. Now, if you have gained value with this video, don't forget to like, share, and leave a good comment. And if you are yet to subscribe, then now is a good time to do so. Also, click the notification bell so you get notified when my future videos are released. In my next video, God willing, we will be computing the deciles for grouped data. See you in the next video, and as always, thanks for watching.